Hi, now we are going to see how to harvest the solar energy. There are different ways of harvesting the solar energy. We'll just first undergo or just learn what are the basics of solar panel or how to you know harvest the solar energy by using this solar panels. So basically, we'll just move on to the different structures of this PV cells. So first we'll understand what is the physics behind it. We have the p-type layer and the n-type layer, and same like the normal diode or semiconductor device, we have this p-n junction. So that's how it's getting, the layer, the sunlight is being converted to electrical energy. So the electrons movement creates the current flow, and this is how we get the solar energy being converted to or harvested to electrical energy. So there are you know different ways of different you know structure in integration or updation. One is the cell, and if we have no more number of cells, then that becomes the module, and if we have a collection of array of modules, then that becomes the array. So this is how we have the solar panel or the solar cells. So basically we have cells, modules, and panels. So this is cells, modules, and arrays. This is how the structure goes. So a cell is one which is having only one simple structure, and if we have more number of cells, collective cells forms a module, and collective modules forms the array. Now let us understand what is the cell, modules, and arrays are for. Uh, Very simple. A photovoltaic cell or a solar cell is the basic building block of a solar system or a photovoltaic system. So this individual cell is actually small, which is actually produce, or typically it just produces 1 or 2 watts of power. So when you go for small sort of projects, school kids or school projects, they usually have a single cell. Okay, you could have seen that. So that is actually for 1 or 2 watts of power, which actually generates for a small scale of power. So this, if in case we want a more power compared to the cell or the 1 or 2 watts, then we want to boost the power. For that, we will be in need of more number of cells. So to achieve that, we'll be having more number of cells connected as modules. So that forms a larger unit compared to the previous one. So this is how the boosting happens, and the output power is increased. Now, for the normal, solar harvesting that is achieved in our homes or industries or anywhere wherever small scale sort of thing, there we have arrays, means as we have seen in the previous picture, we have the cells array, module, and a more number of modules forms, or cumulative modules form an array. So that gives more number of power, or which is, if we integrate it in a proper way, either series or parallel, whatever it is, by connecting these cells, then mostly in series, the output voltage is actually increased. On the other hand, the output current can reach higher values by connecting the cells in parallel also. Now, based on the sunlight collection method, photovoltaic systems can be even classified into two general categories, namely flat plane systems or concentrator systems. Now we should know what is this and how this actually impact have an impact on the uh, power generation. So this is a different way, or the sun collection method estimates or has an impact on the power generation. So first we'll see what is flat panel PV system, which this is very simple. This directly captures the sunlight, or they use the diffused sunlight from the environment. So they can be fixed or combined with the sun tracking system. Either you can have, or you just have it in a separate way. Whereas on the other hand, concentrated systems collect a large amount of sunlight and concentrate and focus the sunlight to target the PV panels using lenses and reflectors. So it's unlike the flat panel, this concentrator has some reflectors or lenses. So these systems reduce the size and required number of cells, while the power output is increased. Moreover, by concentrating the solar light, the efficiency of the PV cell is also increased. Okay, so we'll move on to the next part. which is actually the types of materials or the semiconductor materials in the different types of materials in a PV cell. So PV devices can be made from various types of semiconductor materials, either deposited or arranged in thin film. There are basically three main types of materials used for solar cells. They are silicon, polycrystalline thin films, and single crystalline. So the first type is a single silicon type, which can be used in various forms, including single crystalline, multicrystalline, and amorphous. Likewise, the second type is a polycrystalline thin films with a specific discussion of copper, indium diselenide, cadmium telluride, and thin film silicon. Finally, the third type of material is the single crystalline thin film, focusing especially on cells made from gallium arsenide. We call it as GaS. So first is silicon. This includes, as we said, has three types. It can be a single crystalline Si or multicrystalline silicon or amorphous silicon. So silicon can be used to make more. Some of the earliest PV devices is still most popular actually among our material for the solar cells. Outranked only by oxygen, silicon is also the second most abundant element in the Earth's crust. However, to be useful as a semiconductor material in solar cells, silicon must be refined to a purity of 99.99%. So in single crystal silicon, the molecular structure, which is arrangement of atoms in the material, is uniform because the entire structure is grown from the same material. So this uniformity is ideal for transferring electrons efficiently through the material. To make an effective PV cell, silicon has to be doped with other elements to make it N-type or P-type. Moving on to the semicrystalline type of silicon, in contrast to the earlier case, consists of several smaller crystals or grains which introduce boundaries. These boundaries impede the flow of electrons and encourage them to recombine with holes to reduce the power output of the solar cell. Semicrystalline silicon is much less expensive to produce than the single crystalline silicon. Moving on to the second type, polycrystalline thin films type, including this copper indium diselenide, cadmium telluride, and thin film silicon. All these are coming under this category. So another scientific discovery of the computer semiconductor industry, which vitally impacted the PV industry or the photovoltaic industry, is the thin film technology. The thin film term actually comes from the method used to deposit the film, not from the thinness of the film. So it is actually comes from the method used to deposit the film. Thin film cells are actually deposited in very thin consecutive layer of atoms, molecules, or ions. So the thin film cells have many advantages over the thick film counterparts. For an example, they use much less material. The cell's active area is usually only 1 to 10 micrometer thick, whereas thick films are typically 100 to 300 micrometer thick. So this is how it varies and there's an impact. Thin film cells can usually be manufactured in a large area process, which can be an automated continuous production process. Finally, they can be deposited on flexible substrate materials also. So the last type is actually the single crystalline thin film. This includes high efficiency materials such as gallium arsenide, which is a compound semiconductor. This is a mixture of two elements, gallium and arsenic. Gallium is a byproduct of smelting of through metals, notably aluminum and zinc, and it is very rare than gold. Arsenic is not rare, but it is poisonous. So gallium arsenide was developed for use in solar cells at about the same time that it was developed for the light emitting diodes, LEDs, lasers, and other electronic devices that uses light. So we'll just see the image of the different types of solar panels. So this is the monocrystalline, this is the polycrystalline, and this is the thin film. So you could have seen this type of solar panel as a cell in the small school projects or a mini project or some small scale projects for the low power applications. So you could have seen this type of cells. So you can see how the difference. This is most expensive, this is cheapest, this is average, and it can withstand this much of degrees. And So this is up to the efficiency percentage. So this is another molecular or the cell structures for the different types monocrystalline, polycrystalline, amorphous. So with this type of solar panels come to an end. Moving on to the next type is actually solar energy systems. Typically, the solar energy systems are classified into two systems, active and passive system. So what is active and passive? A passive solar energy system do not involve panel systems or other moving mechanisms to produce energy. Passive systems utilize non-mechanical techniques to control the amount of captured sunlight and distribute this energy into useful forms such as heating, lighting, cooling, and ventilation. These techniques include selecting materials with favorable thermal properties to absorb and retain energy, designing spaces that naturally circulate air to transfer energy, and also referencing the position of a building to the sun to enhance the energy capture. In some cases, passive solar devices can be used or can be composed of moving parts with the distinction that this movement is automatic and directly powered by the sun. So these systems can be used for heating and lighting purposes. Moving on to the active solar systems, typically involve electrical and mechanical components such as tracking mechanisms, pumps, fans to capture sunlight and process it into usable forms such as heating, lighting, and electricity. The panels are oriented to maximize exposure to the sun. Depending on the system, the panels will then convert sunlight into electricity, which is then transferred from DC to AC form and stored in batteries or fed it into the local utility grid. Active systems are more expensive and complex. Now, moving on to the components of the solar energy system. In this system, sunlight is captured by the PV array. The sun tracking system tracks the photodiode or the photosensor signals and determines the sun tracking motor positions. Therefore, daily and seasonal solar position changes are followed in order to face the sun directly and capture the most available sunlight. You can see you can either connect it to the domestic loads or to the grid also. So we capture the sunlight through the cells or the arrays or modules, whatever it is, and then it is through the MPPT we convert it, and for that we may have the sun tracking system. We may or we may not, based on the range of power that we require. But it is best to have a sun tracking system based on the sunlight position. We can track and accordingly we can capture that. For that we need this MPPT, maximum power transfer, power point transfer. So we need a sensor and sun tracking system, and the motor position controller controls the motor position according to the sunlight. And after capturing this, it is converted from, or it is actually DC voltage, which is actually boosted through the DC-DC converter. It's a chopper, and then we can just pass it on to the battery pack, nothing but to store it. Then we can pass it on to the inverter, which is DC to AC conversion, and this AC is either fed it to the normal domestic loads for a small residential application, or you can just connect it to the grid also. It can be for a local use or for any grid connection also. So these are the different types of mounting systems. So according to the orientation, we get the power extraction. So this is fixed, so you can't move this, whereas this is adjustable. So whereas this is tracking, so it is both rotational as well as sliding part is given. Next is actually we'll be concentrating the characteristics. So this is very simple. This is a IV means current voltage characteristics based on the different short circuit PV panels, current and the levels of the PV panel. So we can observe that at specific point it is reaching to a saturation or it is coming down. Likewise, this is the graph for the current and power for the solar cell or the PV panel for different short circuit current values. So combining that, we'll get the next one. This is for one cell and two cell. It's for the series and parallel connection of the ideal cells. So you can just see the difference. So combining the IV curve and the PV curve, we can see that the maximum power point position is attained at this moment, or the Imax and Vmax, and obviously there is a point at which we can drag or we can extract more amount of power, and once that is tracked accordingly, we try to make use of the uh, extraction. So this is how, these are the basic understandings or the basic uh, you know knowledge or ideology of the solar cell or solar energy harvesting. Thank you.